travel by air, you expect safety and convenience at a reasonable price and without delays. Whether you are a pilot, a passenger, or aviation executive, 20 years from now you will still expect that, even with a doubling in traffic. But you won't get it unless there are major changes to today's national airspace system. That's why the FAA is working with public and private partners on the next generation air transportation system. The FAA is also working with international partners to make sure NextGen is compatible with similar efforts around the world. NextGen transforms the way America flies. It uses 21st century technologies to move you from city to city safely, without delay, while reducing aviation's environmental impact. Aviation has outgrown the air traffic infrastructure established 50 years ago when jet engines and radar were new.
When the signals hit an object, such as an airplane,
it's a ground-based system that's used for navigation, for aircraft positioning. It's labor-intensive. It uses voice for communications, radar for surveillance. NextGen is going to be fundamentally different. Satellites for navigation and aircraft positioning, automatic dependent surveillance broadcast, data communications, greater use of modern information technology.
When I think about NextGen, it's kind of back to the future. And I think back to the 1920s, a pilot would load up the passengers, load up the bags, take off when they wanted to take off, fly exactly the route, the altitude, the speed they wanted to fly, land at the destination, have no delay getting to the gate, and never talk to anybody. To a degree, that's what we're trying to do with NextGen. We're trying to facilitate that flight experience every flight, every day to the maximum extent possible, while at the same time maneuvering it through a lot of other traffic.
Demand for aviation services has never been higher, and it's growing at a phenomenal rate. But the current air traffic system is at its limit. Flying from airport to airport takes longer today than at any time in the past 2 decades because of congestion on the ground and in the sky. Rush hour backups in New York can often mean delays throughout the rest of the country.
You get the East Coast corridor, you have a little bit of weather in there, or some sort of a power outage in an air traffic center, or just a minor problem, and it just shuts the whole system down.
The current way we manage air traffic today and the way we rely on aircraft and airports today will not be enough to meet future aviation demand.
Today, delays in the system cost the users of the system at least $9 billion per year, and that's only going to grow as we move into the future. Some estimates say that by 2025, delays could cost $22 billion per year.
I think the cost, if we do nothing, is really measured in terms of the disruption to the economy, to the traveling public, with increased cancellations, endemic delays, across the country. But it's really the kind of societal impact of not having a reliable air transportation system that's the price of doing nothing.
If you ever wonder about the imperative for NextGen, think of what is approaching us right now. We have the A380 just beginning to fly, very light jets into the system, a large population of unmanned aircraft systems. We also have commercial space coming at us. Virgin Galactic is anticipating 2 flights a day by 2010. We're going to be handling all this traffic, and we need a modern system to be able to do it.
Without change, the U.S. risks losing its international leadership in aviation. What's needed now is a nimble approach to safely and efficiently handle increased traffic and new types of aircraft while minimizing the environmental impact. The good news is, it's already happening. One component of NextGen is a satellite-based technology called Automatic Dependent Surveillance Broadcast, or ADS-B.
ADS-B is essentially taking information from the Global Positioning Satellite System, being received inside the aircraft, and taking that navigation information and transforming it into surveillance and provided to the air traffic controllers, and it also gets provided to pilots.
ADS-B offers broader coverage and is more precise than radar, which allows for greater capacity by separating planes more efficiently.
Currently, the FAA has test and demonstration assets up in Alaska where we provide it to the air traffic controllers in Anchorage Center. And also in the lower 48, we have radio stations providing information to pilots where they get the traffic information and weather information in the cockpit.
ADS-B is already in use at the UPS hub in Louisville. It will soon make its debut in the Miami area, followed by Philadelphia. ADS-B is also being installed in the Gulf of Mexico, which lacks radar coverage. There, it will allow controllers to dramatically reduce separation standards, currently at 150 nautical miles, all the way down to 5, significantly increasing the capacity of this popular airspace. ADS-B will allow thousands of helicopters to operate more safely among oil rigs.
We have low-altitude helicopter operations, and then we have high-altitude air carrier type operations. And so it's a boon for us because it's non-radar airspace, so we'll be able to demonstrate how you can extend the national airspace system into the Gulf, providing surveillance where we currently do not have it.
NextGen also has environmental benefits. It allows the pilot to fly the most efficient route possible, reducing fuel usage, emissions, and noise, as well as reducing travel time.
The ability to not have long queues at the airport with engines running, putting out pollution into the air, will be able to get aircraft to the end of the runway, off, on their way, and landed as quickly as possible, which is going to be a huge environmental advantage to the way we do things now.
Today, aircraft are enjoying next-gen benefits through the use of satellite-based navigation. Area navigation, or RNAV, uses onboard avionics so planes can fly more direct and precise paths. Required navigation performance builds upon RNAV. It allows pilots to use more precise navigation on arrival and departure, decreasing taxi time, ground delays, and miles flown. Old airspace technology restricts aircraft to the equivalent of a one-lane highway for a given route. NextGen adds more lanes, which helps remove choke points that can be the source of delays at multiple airports.
It's going to help us to relieve a lot of the stress and pressure that the controllers now face in their job. We will go more from a controlling atmosphere to a managing atmosphere in the control rooms. We will have the computer technology, we'll have conflict probe, we'll have a lot of systems in that will take a lot of the separation pressure off of the controllers, and we will truly become aircraft and airspace managers.
With NextGen, aircraft technology improves pilots' ability to safely navigate in bad weather and over difficult terrain.
An aircraft-centric future is about taking advantage of an aircraft today that has all the capability it needs to perform any task anywhere in the world, anytime.
Pilots can land even when weather blocks their view of the runway.
Enhanced vision approaches will enable the crew to see where they are landing. Today, it's a blind landing. You'll be able to see with enhanced flight vision systems the runway environment, the rollout, and taxi to the gate, all presented to you by enhanced flight vision systems.
NextGen data communication allows time-critical information, such as changes in weather conditions, to be sent digitally from air traffic managers to aircraft. This will reduce workloads and complexity that are inherent in voice-only analog communications. System-wide information management provides common and secure information across a digital network to all NAS users.
The advantages of SWIM is that it is digital. We can pass graphical information, pictures, the big picture of what's going on, so that we really get beyond the voice or the very static paper information system that we have today.
The most accurate information will be shared more quickly to allow a common picture of the NAS to be assessed by all users. This will enable pilots and air traffic controllers to share in traffic management decisions. Weather accounts for 70% of flight delays. NextGen increases capacity and improves reliability with new approaches to weather. Data communications and network-enabled weather will allow better coordination to resolve critical weather issues using a shared common weather picture. By combining advanced traffic flow management tools with readily accessible weather information, delays will be reduced and system capacity increased.
On the ground there, we will introduce technologies that will help us immediately at our airports. We're introducing surface management capabilities with NextGen.
Everybody is going to have the same image of what's going on the surface of the airport, whether it's the pilot, the air traffic controller, or someone in a fuel truck or a maintenance truck on the airfield, which means we should see some reductions or great reductions in runway incursions.
NextGen builds on newly installed runway safety technology.
ASDX allows us to not only know where every aircraft on the surface of the airport is, it has technology in it that allows conflict alert for us, so that in case an aircraft is rolling through a hold short line, it will actually give an alert to the controller. Huge safety benefit. Runway status lights at the airport will allow the pilot in the cockpit to know if the runway is occupied. Huge safety advantage. These technologies are here now.
As aircraft fly more precise paths, airports can build more runways closer together to increase efficiency. The highly accurate departure and arrival paths also avoid environmentally sensitive areas, making airports a better neighbor.
Today, we have to have pretty substantial separation between runways, 4,300 feet, to ensure safety and separation between aircraft. In the future, with higher performance in aircraft, we will be able to actually have more flexibility in the design of airports by being able to move them closer in together and allow more increased and different operations.
If you look at the concept of NextGen, there are some things that are already in place and that will be rolling out over the next few years. ADS-B in certain locations, ASDX at airports, new runways themselves, RNP procedures, RNAV procedures, more computerization of the NAS, and in general, all of these are going to be components to making NextGen a reality.
Bottom line, NextGen is transforming all three components of traffic: the airport, the aircraft, and air traffic control. The distance between where we are and where we want to go shrinks every day as proven technology is put into place. And globally, NextGen is being harmonized with modernization efforts in other countries.
As this new capability becomes more pervasive, the price is going to drop. It's going to be like the price drop we've seen with computers. Well, the more that are produced, the larger the production base, the lower the price gets.
The building blocks are in place. Now all of us need to go the distance.
Both the public and the private community, airplane owners and operators, need to make investments, and they have to make the investments together.
The next generation of flight is underway.